question number 51, which is related to the buffer, and you have to identify which of the following is an acidic buffer. So first of all, students, tell me what do you mean by acidic buffer. So acidic buffer is a mixture of weak acid and salt of its acid with strong base. So this is the acidic buffer. So now find out acidic buffer in the options. In the first option you have HBr and KBr. So as you know that HBr is a very strong acid. So जो acidic buffer की condition थी that it should be a weak acid, it is not fulfilled. So this option is incorrect. So now you have the second option in which you have H3PO4 and Na3PO4. And in this case you know that H3PO4 is a tri-basic acid and it is a weak acid. And Na3PO4 क्या है? It is a salt of acid, that is H3PO4 with strong base NaOH. So this our condition is fulfilled now. So this will be our correct answer. Now you have the third option in which you have NH4OH and NH4Cl. And you know that NH4OH क्या है? एक weak base है. And NH4Cl is a salt of a weak base with the strong acid, that is HCl. So it is an example of basic buffer, not the acidic buffer. So this option is also incorrect. So now you have the fourth option in which you have NaOH and NaCl. And NaOH आपको पता है, it is a strong base. So यहीं पर हमारी condition क्या हो गई? Not fulfilled, because we need a weak acid. So only correct option that we have found out, that is option number 2. So students, I hope this is clear to you. So let's move on to the next one now. You have question number 52. So it says that which of the following would cause forward shift in the given reaction. So this question is an application for Le-Chatelier's principle. So you have been given a reaction, that is N2 gas and H2 gas is forming ammonia. And as the energy is released, so it is an exothermic reaction. So now in the first option, we are increasing the temperature. So since the reaction is exothermic, increasing the temperature will cause a backward shift in the reaction, because this reaction is favored by low temperature conditions. So if we increase the temperature, there will be a backward shift in the reaction. अब हम देखते हैं, we have the second option in which we are decreasing the pressure. So अगर हम इस reaction में decrease करते हैं pressure, so the reaction will go in that direction where the number of moles are highest, क्योंकि वहां पे सबसे ज्यादा pressure होगा. अब देखते हैं number of moles किस side में ज्यादा है. So number of moles are highest in reactant side. So the reaction will shift in the backward direction. So here also backward shift is observed. And now we are adding the inert gas like helium at constant pressure. So whenever you come across with the phenomena of addition of inert gas, so always see whether it is given at constant pressure or constant volume. Because अगर constant volume पे है, so there is no effect in the equilibrium. अगर constant pressure पे है, so the reaction will move in that direction where the number of moles are highest. So number of moles are highest are in the reactant side. So here also the backward shift is observed. So यहाँ पे भी क्या हो जाएगी? Backward shift. And in the fourth option, we are adding the HCl gas. So addition of HCl gas will cause a reaction with NH3 and will form NH4Cl. So इसका मतलब we are decreasing the amount of the product. So जहाँ पे product का amount decrease होगा, so reaction will move in the forward direction. So here a forward shift in the reaction is observed. So यहाँ पे we will have the answer, that is option number 4. So let's move on to the next one. We have question number 53, which says that the van der Waals equation for 1 mole of a real gas at low pressure is. So this is a very frequently asked question. So first of all, write down the van der Waals equation for 1 mole of a real gas. So that you should remember, that is P plus A by V square, B minus B equal to RT. And now you have to find out the equation at low pressure. So means जहाँ पे pressure कम है, the volume will be higher because pressure is inversely proportional to volume. So volume highest है, इसका मतलब the V minus B को हम क्या लिख सकते हैं? V. So we can write it like this: P plus A by V square multiplied by V equal to RT. So we can rearrange the equation: PV plus A by V equal to RT. So PV will be equal to RT minus A by V. So this is our desired equation. So option number 1 will be the correct answer. So let's move on to the next one now. We have question number 54, which says that the solubility of aluminium hydroxide in decimolar KOH solution, and you have been given the KSP of aluminium hydroxide. So first of all, write the dissociation of AlOH3. So it will produce Al3 plus and 3OH negative. So we can write it like this: 1 minus S, here S and here 3S, where S is the solubility. And you have also decimolar KOH solution. So since KOH is a very strong electrolyte, so it will dissociate completely to form K plus and OH negative. So the concentration given is decimolar. So OH minus की concentration हो जाएगी 10 raised to the power minus 1 molar, that is equal to 0.1 molar. So in the above equation also it will be 3S plus 0.1. So now write down the expression for KSP. So it will be equal to concentration of Al3 plus multiplied by concentration of OH minus cube, because the stoichiometric coefficient of OH minus equal to 3. So Al3 plus the concentration we have, that is S, into 3S plus 0.1 cube. So now since the solubility product of aluminium hydroxide is very low, so the value of solubility will be very low. So 3S plus 0.1 is nearly equal to 0.1. We can say that. So here will be equal to S into 0.1 cube. And the value of KSP is 1.90 into 10 raised to the power minus 33. So if we calculate the solubility, it will be equal to 1.90 into 10 raised to the power minus 30. So option number 2 will be our correct answer. So moving on to the next one now, you have question number 55, which says that at 300 Kelvin, the value of Kc by Kp will be lowest for. So first of all, what is the relation between Kp and Kc? So it is equal to Kp is equal to Kc RT delta Ng. where delta Ng is the difference in number of moles of gaseous products and gaseous reactants. So for the first reaction, you can see here delta Ng will be equal to 2 minus 2. So it is equal to 0. So you can write the expression for Kp. So Kp is equals to Kc RT to the power 0. So here Kp will be equal to Kc. So Kc by Kp will be equal to 1. So I hope this is clear to you. Now you have the second equation in which the ammonia is being formed. So you can see here delta Ng is equal to 2 minus 4, which is equal to minus 2. So here Kp is equal to Kc RT to the power minus 2. So we can say that Kc by Kp is equal to RT square. I hope this is clear to you. And now you have the third equation in which the delta Ng is equal to 2 minus 1 means 1. So here Kp will be equal to Kc RT to the power 1. So यहाँ पे हो जाएगा Kc by Kp is equal to 1 by RT. So now you have the fourth equation in which delta Ng is equal to 2 minus 2 means 0. So this is similar to the first case. So the Kc by Kp equal to 1. So now you have to find out the value of Kc by Kp will be lowest for. So as you can see here, the value of Kc by Kp is lowest for the third case because temperature is 300 Kelvin and the value of gas constant is 0.0821 liter atmosphere per mole per Kelvin. So option number 3 will be our correct answer. So students, let's move on to the next one now.